In this lesson, we're going to be doing objects. Our lesson objectives: discuss what objects are and their importance, and then look at some sample objects and their operations. So, when you're writing a program, you are for the most part creating or instantiating, in other words, and manipulating an object. So when Java is a object-oriented programming, and although we haven't done much of the object-oriented programming, a lot of stuff we're going to be doing after this section is in regards to object-oriented programming. So we're going to be creating objects, we're going to be instantiating objects, and then we're going to be manipulating these objects so that they can be used in a broader scope. The objects consist of attributes such as instant variables, and they're used to create the actual object itself, and then the operations such as the methods that we use in the class are used to manipulate it. So we have instance variables; those are considered the attributes of the object, and then we're going to have operations through methods that allow us to manipulate or change the state of the object. So let's say we have a lock object and you want to enter a code to see if it will unlock your phone. Well, an object would most likely be a lock. We have a lock object, and one of the instance variables, or if not the only instance variable, would most likely be a passcode. So it could be an integer passcode, such as the one on your iPhone. So if it has a integer 1, then our instance variable is most likely going to be an integer. So it's going to be like int lock is equal to whatever the passcode that we set when we created the object or created the lock. And then there's different operations that we have for a lock. So we needed to read the passcode to ensure that, if I enter a value into the lock, then it will unlock or it will understand it. Then it will test the passcode to see whether or not the passcode that we entered actually works. And then let's say if we want a new passcode, then after reading and testing our old passcode to see, we are the actual person that owns this lock, then we can write our own passcode through this operations. So the operations, such as these reading passcode, test passcode, and the write new passcode, are operations that allow us to change an attribute, such as the actual password in the lock object, which all comes together to make the lock object. So let's look at your school's textbook system. So there's two types of behaviors that we're going to exhibit within a textbook. Different states and then different behaviors that we would want from our school's textbook system. So we have a textbook object, and what is that textbook object going to have? Well, that textbook object is probably going to have a title, right, like most textbooks have. It's going to have a location in the library or location in the school where you would want to locate it. What subject or which one of your school's departments does it belong to? Check whether or not a student has checked it out or has been using it for this semester, or it's free. And then if it is taken, then maybe we should set a student owner so that textbook object has multiple behaviors or multiple ways of accessing its instance variables. So if we want to check our textbook from our school system, we can easily get the title, we can easily track the location. If we want to know what subject it belongs to or where in the school it belongs to, we have a operation that allows us to get the subject of the book. We can see whether or not it's taken. Most likely it's going to be a true or false variable with the Boolean expression. And then we can set a student owner or even get a student owner. Now, we can also create a list of textbook objects, and that allows us to store a bunch of textbooks into one object. So we're going to create this one, class, or rather one object, and that's going to encompass all the textbooks that we have, and that ultimately allows us to create our textbook system. So the textbook object itself is just the characteristics and operations for one textbook. However, when we combine or create a bunch of textbooks and then put that in its own object itself, and then have operations such as adding a textbook or removing a textbook, searching our databases, or sorting the textbooks based on some characteristic, then we have a system that allows us to not only track a textbook, but sort them and distribute them to a school system. And a perfect example of an object that we've been using many times throughout this course is the scanner object, and it has a bunch of operations. These are just three that we've listed because these are the ones that you're probably going to use when you're doing Java programming. So what we do is we create a scanner because the scanner is actually an object. That's what the name of the object is, or the name of the class we'll get to most likely in the next video. But the name of the object is actually called scanner, and then we put a name on that scanner. So although the name of the class is scanner, the name of the object is scanner. It's like saying, I'm a human, you're a human, we're all humans, right? So if we're all humans, then this is most likely, if I declare, it's going to be all scanners. But how do we identify a scanner from another scanner? How do I identify another human from another human? We make an identifier. So I put Fozon scanner as my identifier. So that's what I named my scanner. This is an identifier. So whenever I want to access my scanner, right, now the computer knows, all right, I first want to access a scanner, but then which scanner? Because I can have multiple scanners. I don't have to have just one scanner. So it uses this identifier and then creates a new scanner. This is an assignment operator. You know this from our integer primitive types and the string video. And it actually roughly follows the same declaration. When we declare a primitive type or a string type, we have integer, and then we name that integer because we can have multiple integers, but how do we differentiate them from different integers in the same class? Because we don't want the computer to mix up two different integers. So we have an identifier, and then we set that equal to it so that it can declare the scanner, so that it can declare our scanner object. So now the scanner object is going to be created using this statement. Now, normally it's not going to have a system.in statement. Oh, I think I mixed it. All right, there you go. Now, normally when we're creating objects, we will have the new keyword. And this tells the computer that I want a new object. And most likely what will follow is the name of the class. So most likely it's going to have whatever this value is, scanner. Since we're making a scanner object, then we're telling the computer that we want a scanner object. Now, you don't really have to know what system.in means because most likely you're not going to be using that later in this course. However, just to keep you informed about this, because we might use the arguments, the parentheses emphasize an argument. So we can create an object, and then we can make we can send out values through these parentheses. Now, I'm not going to show you through this video, but just know that in the future, we're going to be going more in depth about this. But for now, all you have to know is that this part of the declaration actually declares the value, and then the second half of it actually creates it, declares it. So now it exists, but now how do we make it, right? It's like making a human, but you didn't put the insides in it yet, right? So we know there's a human, but it doesn't really operate. So we have the new scanner that tells us, all right, we have a new scanner and it's created. And then these parentheses are like our arguments. Alrighty, so with the next statement, it says string name. So I want to get user input because this is the scanner object allows us to get user input from the user. So what I do is I have a string name, and then I set that equal to, because I want to declare a string object. So I'm creating a string object. Now remember that integers and primitive types and string are not like normal objects because they are built in the compiler or imported, and they have a much more lenient or much more faster way of creating those objects. So we use those methods. Every time I touch it, it's moving the value. Anyway, so I have, if I want to access the scanner, I have Fozon scanner because that's the identifier. That's the name that I gave to my scanner. Now I can make another scanner and name it someone else's scanner equal to new scanner system.in. But if I want to access Fozon scanner, I use the name Fozon scanner to actually access it. And then when I want to use an operation such as getting an integer, getting a double, getting a Boolean value, or getting a string value through next line, I have these operations that I have here with the parentheses to emphasize that I'm getting or accessing one of the methods. I'm accessing an operation of the scanner object. So that allows us to use the scanner object and then actually execute a operation. Alrighty, now we're on the object reference. When we create an object in Java, the variable that the object is known is an object reference. So Foson scanner is going to be an object reference. So scanner, again, that's the name of our class. Foson scanner is the name that we give that object. So remember, scanner is the name or like the type of object. Foson scanner is the name that we give that object. New scanner most likely will follow, or most likely will be the name of the object. When I mean by name of the object, I mean the type of the object. So scanner, if the first value is scanner, then when after the value new, we're going to have scanner. And then whenever we reference it, whenever we want to access the my scanner, we call it by Foson scanner or whatever name that you put there. Again, it's subject to whatever you put there. Whereas scanner, you need to write scanner no matter what when you're creating a scanner object. So for the final slide of the day, I want you to create a sandwich object and list both its attributes and operations. So what I mean by attributes, I mean things that are part of a sandwich, like, that you would normally have in a sandwich object. So when you create a sandwich, such as a peanut butter sandwich, I'm giving too much away, but if you have a sandwich, what are you going to put in it? And then operations, such as if you want to do something with the sandwich. I'm not talking about like eating, but like the actual creation of the sandwich. So pause the video and basically create your own sandwich object and list both its attributes and operations. Alrighty, so I hope you managed that. This is what I have for attributes. I have some, bread. I have some meat. Again, if you're a vegetarian, you don't have to add meat, but you also have some cheese and you have some vegetables. So when I create my object, when I have a object such as a sandwich, I'm most likely going to have these values as a string value, and when like such as string bread, string meat. String meat might be equal to chicken. String cheese might be equal to American cheese. String vegetables might be equal to tomatoes, whatever. Stuff like that. Stuff that describes the object are instance variables. And then we have different operations, such as add bread, add meat, add cheese, add vegetables. Maybe we did something wrong in one of our operations, such as maybe we're adding a certain meat that we don't want. So we can remove a meat from our sandwich. We can also remove a cheese. We can also remove a vegetables. Now you're probably thinking, wow, that's maybe my answer is a little bit different. Don't worry about it. As long as you got the gist of it, you have different attributes for sandwich objects and you have different operations. I'm just trying to let you get an object from real life and then try to describe it in terms of an object inside the compiler. So now we're just breaking it down and putting it in terms of how we can later on use it with the Java programming language. And this allows us to do one of the very powerful application of computer science, which is object-oriented programming. So you might even see this at your fast food restaurants nowadays. They're making machines that allow you to customize your burgers, that allow you to customize your meal. So what do? You create maybe a Big Mac object. You may create a soda object, and then you could be like, all right, let's add Coca-Cola. Wait, no, I don't want Coca-Cola. Remove Coca-Cola. Let's add Pepsi. And this is the power of object-oriented programming. And there's so many more applications. You just need to, experiment.